Hey guys, I'm going to be reading 176 through 181 in the Venus and Lunar packet. I'm not going to go over the questions with you guys. I'm going to do that on Wednesday during our live session. And I will upload the vocab terms by Wednesday too, so you guys have everything you need. So here we go. Earthquake. One of the most frightening and destructive phenomena of nature is a severe earthquake and its terrible after effects. An earthquake is a sudden movement of the earth. It is caused by the abrupt release of energy within the earth that has built up over a long time. For hundreds of millions of years, the forces of plate tectonics have shaped our planet. The huge plates that form the Earth's surface slowly move over, under, and past each other. Sometimes the movement is gradual. At other times, the plates are locked together, unable to release the accumulating energy. When the accumulated energy grows strong enough, the plates break free. If the earthquake occurs in a populated area, it may cause many deaths and injuries and extensive property damage. Where earthquakes occur. The Earth is formed of several layers that have very different properties. The outer layer, called the crust, varies from 80 to 50 kilometers or 5 to 31 miles in thickness and consists of about a dozen large, irregularly shaped plates. Most earthquakes occur at the boundaries where the plates meet. In fact, the locations of earthquakes and the kinds of ruptures they produce help scientists define the plate boundaries. There are three types of plate boundaries: spreading zones, transform faults, and subduction zones. At spreading zones, molten rock rises, pushing two plates apart. Most spreading zones are found in oceans. For example, the North American and Eurasian plates are spreading apart along the mid-Atlantic ridge. Spreading zones usually have earthquakes at shallow depths. Transform faults are found where plates slide past one another. An example is the San Andreas Fault along the coast of California. Earthquakes at transform faults tend to occur at shallow depths. Subduction zones are found where one plate overrides another. Here, one plate is pushed down into the mantle. One example is found along the northwest coast of the United States, western Canada, and southern Alaska. These zones often have deep ocean trenches, shallow to deep earthquakes, and mountain ranges containing active volcanoes. A fault is a fracture in the Earth's crust along with two blocks of the crust have slipped with respect to each other. Faults are divided into three main groups depending on how they move. Normal faults occur in response to pulling or tension. The overlay block moves down the dip of the fault plane. Thrust or reverse faults occur in response to squeezing or compression. The overlying block moves up the dip of the fault plane. Strike slip or lateral faults occur in response to either type of stress. The blocks move horizontally past one another. The focal depth of an earthquake is the depth from the Earth's surface to the region where an earthquake originates. The focus. The focus of deep earthquakes may be as deep as 700 kilometers or 435 miles. The depth to the center of the Earth's core is about 6,370 kilometers or 3,960 miles. Therefore, even the deepest earthquakes originate in relatively shallow parts of the Earth's interior. The epicenter of an earthquake is the point on the Earth's surface directly above the focus. The location of an earthquake is described by the position of its epicenter and its focal depth. How earthquakes happen. An earthquake is the vibration of the Earth's surface that gathers a release of energy in the crust. This energy can be generated by a sudden dislocation of segments of the crust. It can also be generated by a volcanic eruption or man-made explosions. At first, the crust may bend. Then, when the stress exceeds the strength of the rocks, the crust breaks and snaps to a new position. During this process, vibrations called seismic waves are generated. These waves travel outward along the surface and through the earth. Some of the vibrations are audible, while others are not. These vibrations cause the entire planet to quiver or ring like a bell or tuning fork. Geologists have found that earthquakes tend to recur along faults. Even if a fault zone has recently had an earthquake, another could still occur. In New Madrid, Missouri, a great earthquake was followed by a large aftershock within 6 hours on December 6, 1811. Relieving stress along one part of the fault may increase stress in another part. The New Madrid earthquakes in 1812 may have resulted from this phenomenon. Earthquake waves. The vibrations produced by earthquakes are detected, recorded, and measured by instruments called seismographs. The seismograph responds to the motion of the ground below it. The zigzag line of the seismograph reflects the changing intensity of the vibrations. There are two general types of vibrations produced by earthquakes. Surface waves travel along the Earth's surface. Body waves travel through the Earth. Surface waves usually have the stronger vibrations. They probably cause most of the damage done by earthquakes. Body waves are two types, compressional and shear. Both types pass from earthquake's focus to distant points on the surface. However, only compressional waves travel through the Earth's molten core. Compressional waves travel at great speeds and ordinarily reach the surface first. They are often called primary waves or P waves. P waves cause tiny particles of Earth material directly ahead or behind them to move. Shear waves do not travel as rapidly as do compressional waves. Because they ordinarily reach the surface later, they are called secondary or S waves. They don't affect material directly behind or ahead of their line of travel as do P waves. Instead, shear waves displace material at right angles to their path. They are therefore sometimes called transverse waves. The first indication of an earthquake is often a sharp thud. This noise signals the arrival of compressional waves. Next come the shear waves. Third is the ground roll caused by the surface waves. A geologist who was at Valdez, Alaska during the 1964 earthquake described the sequence. The first tremors were hard enough to stop a moving person, and shock waves were immediately noticeable on the surface of the ground. These shock waves continued with rather long frequency, which gave the observer an impression of a rolling feeling than abrupt hard jolts. After about 1 minute, the strength of the shock waves increased in intensity. Failures in buildings as well as the frozen ground surface began to occur. About 3.5 minutes, the severe shock waves ended and people began to react as could be expected. How earthquakes are measured. An earthquake's severity can be expressed in several ways. The magnitude of an earthquake is a measure of the strength of the seismic waves. Magnitude is usually expressed by the Richter scale. The moment magnitude is a measure of the amount of energy released.